some terminology. When I talk about the solution, I'm asking for an ordered pair that makes them both true. So if you plug it in, it works for both. If it has a solution, we call it consistent. So if you solve it and you just get one answer, that's consistent. That means, I put here the equations are independent. You have two different equations, so it would be like two lines that meet in one point. And this is your solution. That's consistent, independent. They meet, they only meet once, you can list that point, that's your answer. If it's infinite solutions, it's called consistent and dependent. So infinite solutions would be when you have two equations and they're the exact same line. So it's consistent, you can find points that make them both true, but they are dependent because they are the same line. So it's every point on that line makes it true. The third option is inconsistent. That means you don't get any answers. What kind of lines would never meet?
Parallel.
Parallel. So you did this in Algebra 2. My Algebra 2 just took a test over it before break. Do you remember talking about these terms? Consistent, inconsistent? Our options in Algebra 2, the first way we solved these was by graphing. Graphing works great if your answers are pretty. But when your answers start being decimals, the graphing isn't real accurate. So I am going to go ahead and just skip that method for now. The other two options that always worked were substitution and elimination. So that's what I'm going to focus on. So we'll try to recap both of those and make sure we remember. I've got a couple examples. If I do the first one and you want me to move on to the next one, just tell me and we'll skip the next and move on. Or if you need extra practice, just let me know. You have to kind of let me know what you remember. Are we ready to solve one? Let's do this one. So I want you to solve this by substitution. What do you remember about substitution? Right, you take one of the equations, you solve for one of the variables, and you plug it into the second equation. Does it matter which one we use? No. So what do you want to solve for? The bottom equation, you want to solve for x? Okay. So if I took this equation and solved for x, I would just add my y over. So x equals 4 plus y. Then what do you do with that? Into the first equation. So instead of x, I'm going to do 4 plus y equals 8. So if I subtract my 4, divide by 2, I get y equals 2. Once I have my y, what do I need to do? Plug it in to get x. So I'm going to plug it in right here. X is 4 plus y, which was 2. So x is 6. So my answer is the ordered pair 6, 2. I didn't ask for the classification, but we got a solution, so it's consistent. We only got one solution, so it's independent. I asked for that classification. What questions do you have there? Do we need another substitution? You guys remember that look at elimination. Okay, what's elimination? Right. We want to be able to add these equations together and get something to cancel. So, if I want to cancel my x, what would I have to do? Take the top one times 2. If I wanted to cancel my y, what would I do?
At the top 6.
Top by negative 6, because they have to have opposite signs. Okay, so then if we add these equations together, negative 4x and positive 4x cancel. I have 8y equals 22. Divide by 8. Get 11/4 or 2.75. We have y. How do we find x? Plug it in for x. So you can use either equation. I'll just go with the first one. I don't care if you use fractions or decimals as long as your answer is exact. So if it comes out to be 0.3 repeating, don't just call that 0.3. Go ahead and write that one as 1/3. But if it's 0.75, I don't care which one you do. You have 2x equals 9/4. So x is 9/8 or 1.125. What you got? So final answer is F1. Yes, this would be consistent and independent as well. Other questions? Let's say do this. Okay, so I've given you both methods. Now we can pick what we want to use. Elimination would work. If you were going to use substitution, which one would you probably solve for? The top one for y. That way you could avoid fractions, but elimination works too. So what am I going to have to do for elimination? Okay. So I get negative 4x minus 2y equals negative 10. I didn't change the second one. Will you ever have to multiply both equations by something? Sometimes, and that's fine. When I add, my x's drop and my y's drop, so I have 0 equals negative 2. What does that mean? No solution. What do we call it if there's no solution? Okay. Let's look at What do you want to do? So if I take the top times -2, that gives me -2x minus 4y equals -8. What happens when you add these?
Infinite solutions.
You get 0 equals 0. In Algebra 2, you just wrote infinite solutions. This is consistent, but they're the same line, so they're dependent. We are going to write our answers a little bit different. What I'm going to usually say in this situation is write the answer with y arbitrary. So instead of just saying it's infinite solutions, it's every point on the line, you are going to actually describe what kind of points fall on that line. So you are going to give me an ordered pair. If I say y is arbitrary, you're going to keep y as y. But we have to find some expression for x. So you have to go to one of your original equations and solve for x. Which one do you want to use? Top one. If I solve for x, you just subtract your 2y. So x is 4 minus 2y. So this gives you a description of what all the ordered pairs on that line look like.
Why do we do that for the y and not?
It'll be based on the directions. If I said x arbitrary, you would leave x and then solve for y. Other questions? Let's look at this problem. How is it different?
Got the square root.
It's got a square in it. It's not a linear one. If it's not linear, that means we could get more than one answer. Okay. What we're going to do is still try to eliminate a variable. But in this case, we really have, in a way, 3 variables. We have the x squared, we have the x, and we have the y. What's the one you think we should probably get rid of? The y. Because x squared and x are in terms of the same thing. So, this one I don't really have to do much. If I just add these equations together, my y's drop. So we have x squared plus x, because they're not like terms, you can't add them, equals 2. Now what?
Quadratic one. You use quadratic.
Yeah, let's subtract our 2 over. This is a quadratic, so we try to set those equal to 0. And I believe this one will actually factor nicely. What multiplies to -2 and adds to +1? Okay, so you set each one to 0. I have my x. How do I find my y? Plug it in. Which one do you want to plug it into? Alright, so x plus y equals -2. So that means y equals 0. So my first ordered pair is -2, comma 0. If I put in 1, my y is -3. would like to do at least one more example, and then if you guys are okay, I'll give you some time to work. What do you want to do here?
That's not bad.
Okay, so if we take top times negative 4. Didn't change the second one. So my x squareds drop. Negative 4y squared plus 3y squared would be a negative y squared equals negative 9. Divide your negative. What I have to do is square root. With that goes a plus and a minus. So we get two answers for y. It can be either a positive or a negative 3. Now I need to find my x. So if my y is 3, and I plug that in, I get x squared equals, this would be 9, so if you subtract it over negative 4. What happens when you do the square root of that? So we get plus and minus. Square root of negative 4 would be a 2i. So what we have there are two possibilities. My x could be a 2i, and my y could be 3. Or my x could be a negative 2i, and my y could be 3. Are those my only answers? No, you also have the possibility that y is negative 3. When we do that one, we get the same thing. So we get 2i negative 3 and negative 2i negative 3. So that one we got 4 answers. So really the only difference when you're looking at those nonlinear ones, you're going to get more than one answer. And you will have to pay attention. You might have a quadratic that you need to solve in there. Do we need more problems like any of these? I made a handout and posted it on Classroom, so that's your